Playing sports, running, or even doing something as simple as going down the steps. You and I are able to do all these activities and so much more because of our muscles that honestly we do not give them too much credit. So let's first begin by understanding what they do for us every single day. Let us identify the three muscle types that we have. We have cardiac, smooth, and skeletal muscle. The first two, cardiac and smooth muscles, are considered to be involuntary since we're not able to move them. However, skeletal muscle is the muscle that we're actually able to move via our brain or spinal cord. Skeletal muscles are made up of bundles of muscle fibers that house myofibrils. These myofibrils have sarcomeres that contain thin and thick filaments that are actin and myosin based respectively. At rest, these filaments are not completely overlapping each other. Regarding the actin filaments, it has two regulatory proteins, troponin and tropomyosin. Tropomyosin proteins cover the binding sites on actin, thus making contraction of the sarcomere not possible, since actin is attached to the Z disc. Regarding the thick filaments, the myosin heads are bonded with ATP. Now let's get to the actual contraction phase. Depending on whether or not you're getting a signal from the brain or spinal cord, the signal will go through neurons to a neuromuscular junction. Acetylcholine neurotransmitter molecules are released from a neuron and bind to receptors on the muscle fiber. This binding depolarizes the muscle fiber, and an electrical impulse travels through the T-tubules and opens stores of calcium ions from the sarcoplasmic reticulum. If there is a high concentration of calcium ions and ATP is present, then these ions bind to troponin, which causes tropomyosin to be displaced and reveal the binding sites on actin. Now remember, at rest the myosin heads on the thick filaments are bonded with ATP, and once it becomes hydrolyzed, the ATP becomes ADP and inorganic phosphate. This allows the myosin head to go through what is called a power stroke, which is when it attaches to the binding site on actin and pulls the thin filaments towards the M line, ultimately making the sarcomere shorter without the thin or thick filaments actually becoming shorter. During the power stroke, ADP and inorganic phosphate are released, and the myosin head stays in its contracted phase until another ATP molecule binds. This process repeats itself as long as there is a high concentration of calcium ions and ATP.